Determine the sum to n terms and hence the sum to infinity of the following series with the condition that the absolute value of x is less than 1. Okay, let us begin. Now here we have a series given by 1, so that's the first term, followed by 4x, then we have 7x squared plus 10x cubed. Now this is neither an arithmetic series nor a geometric series, because for a series to be arithmetic, it must have a common difference. Now in our case, if we take any term, so let's take the third term 7x squared, and from here subtract the second term, which is 4x, it's going to give some difference, and that difference does not match if we take the fourth term and subtract the third term format. So only when that criterion is met, we say that the given series is arithmetic, else not. Also, this series is not geometric because it does not have a common ratio. If we take the second term, which is 4x divided by 1, so that gives us a ratio of 4x. But if we take 7x squared and divide it with the previous term 4x, that does not give us the ratio 4x, which means that also it does not have a fixed common ratio. So this series is neither an arithmetic series nor a geometric series. However, this particular series is composed of an arithmetic sequence and a geometric sequence. So here in our case, if we consider the constant terms, so let's say we start with 1 followed by 4, 7, 10. So these terms are going to be in arithmetic progression. They are in arithmetic progression whose first term is 1 and the common difference is 3. That means the nth term, which is given by the formula a plus n minus 1 times the common difference d. So a, that's 1, added to n minus 1 times the common difference, which is 3 in our case. So simplifying this gives us 3n minus 2. So that's going to be the nth term of the arithmetic progression. And if we consider 1 from the first term, x from the second term, x squared from the third term, x cubed from the fourth term, and so on, these terms are going to be in geometric progression. Now here, the first term, that's equals to 1, the common ratio, which can be obtained by taking any term in the sequence and dividing it with the previous term, giving us x. So the common ratio is going to be x, and that gives us the nth term, which is defined by a multiplied to r raised to the power of n minus 1. So we have x raised to the power of n minus 1. Now, for our case, the series, so what we can do, we can easily define the nth term. All we have to do is take the nth term of the arithmetic progression and to it multiply the nth term of the geometric progression. So this is going to give us the nth term of the original series. In other words, the original series is an Arithmetico-Geometric series. Okay, so here we have obtained the nth term of the series. So let's try to find out the sum to n terms. So here what we'll do, we are going to consider the sum to n terms as Sn. So this is going to be equals to 1 plus 4x plus 7x squared plus 10x cubed, or the rest of the terms. We're going to consider the second last term. Now to find out the second last term, what we'll do, we'll consider the nth term of the series, and wherever we see n here, we're going to replace that n value with n minus 1. So when you replace n with n minus 1, then 3n minus 2, that's going to become 3n minus 5. To it, we're going to multiply x raised to the power of, so here replacing n with n minus 1, so that becomes n minus 2. And then we have the nth term, 3n minus 2 multiplied to x raised to the power of n minus 2. Now what we'll do, we will take that same sum Sn, and we are going to multiply each terms with the common ratio of the geometric progression, which is x in our case. So we'll try to find out x Sn. Now when we take x and multiply it with the first term 1, that's going to give us x. Then we have 4x. When we multiply with x, that gives us 4x squared, added to 7x squared times x, that's 7x cubed. This is going to continue. Then we have the second last term. The second last term is 3n minus 5. So we have 3n minus 5. Now when we multiply x to x raised to the power of n minus 2, that simply becomes x raised to the power of n minus 1. Added to, we have 3n minus 2 multiplied to x raised to, this is x raised, this is n minus 1. So when we multiply with x, that becomes x raised to the power of n. Okay, now we're going to subtract. We're going to perform a subtraction here. We will get Sn minus x multiplied to Sn. This is going to be equals to, we have 1 added to 4x minus x, that's going to be 3x, added to 7x squared minus 4x squared, that's 3x squared, added to 3x cubed, all the way up to the second last term. So that means we will take the nth term of Sn and from here subtract the second last term of x xsn. So that's going to give us 3 multiplied to x raised to the power of n minus 1 minus the last term of xsn. So that's 3n minus 2 multiplied to x raised to the power of n. So on the left hand side, we're going to take Sn as the common factor. So that's multiplied to 1 minus x. This is going to be equals to, we're going to keep the first term as it is, and also we're going to leave the last term, which is 3n minus 2 as it is. Now what we'll do, we're going to consider the second term all the way up to the second last term. Now this series is a geometric series. That's because it has a fixed common ratio. Let's take 3x squared and divide it by 3x. So that's going to give us the common ratio r as equals to x. We can verify that if we take 3x cubed, the third term, and divide it with its previous term, 3x squared, that's also going to give us the common ratio as x. Here, the first term a, that's going to be 3x. And how many terms are there? So there are in total of n minus 1 terms. Now let's verify that why there are n minus 1 terms. When we considered Sn, we exclude the first term and consider the second term all the way up to the last term. So that means in total, Sn means there are in total of n terms. If we exclude one of the term, that's going to leave us with n minus 1 number of terms. Similarly, in xsn, we're going to consider the first term all the way up to the second last term. And here we are going to exclude the last term. So that's also going to leave us with n minus 1 number of terms. Now, when we subtract n minus 1 terms of Sn with the n minus 1 terms of xsn, the result is going to have n minus 1 number of terms. So here we can easily find out the sum up to n terms of the geometric series, because we have a standard formula to find out the sum to n terms of a geometric series, which is given by the first term multiplied to 1 minus the common ratio. Common ratio will be raised to the power of total number of terms, which is n, divided by 1 minus the common ratio. This is the general formula. So we will use this formula to define the sum to n terms of the given geometric series. So first term, that comes out to be 3x. So this will get multiplied to 1 minus the common ratio, which is x, raised to the power of total number of terms. Now there are n minus terms here, so we have x raised to the power of n minus 1 whole divided by 1 minus the common ratio, so that's x. Fine. Now what we'll do, we're going to divide throughout with 1 minus x. So we're going to get Sn equals to 1 over 1 minus x added to 3x multiplied to 1 minus x raised to the power of n minus 1 whole divided by 1 minus x whole square, minus we have 3n minus 2 multiplied to x raised to the power of n whole divided by 1 minus x. So this is going to be the sum to n terms of the arithmetico-geometric series given by 1 plus 4x, 7x squared plus 10x cubed, and so on. Now, we also need to find out the sum to infinity. So that means when we have n going to infinity, that means we have an infinite number of terms. Now, if we have an infinite number of terms, we are also provided with the condition that x is, the absolute value of x is less than 1, which means that the common ratio xs could be half, or it could be 1/3, or any value which is going to be less than 1. So with the condition that the absolute value of x is less than 1, and when n goes to infinity, then x raised to the power of n minus 1, this is going to go to 0. And x raised to the power of n, that's also going to 0. Which means that now sum to infinity for the first term, that's exactly going to stay as 1 over 1 minus x. Now for the second term, we have 3x multiplied to 1 minus. So x raised to the power of n minus 1, that's going to go to 0. Divided by 1 minus x whole squared. Minus, we have 3n minus 2 multiplied to x raised to the power of n, then that goes to 0. Divided by 1 minus x. Now further simplification, we have s infinity. That's going to be 1 over 1 minus x added to 3x over 1 minus x whole square. So combining them, we're going to get 1 plus 2x whole divided by 1 minus x whole square. So we have successfully obtained the sum up to the infinite terms, and we also have the sum up to n terms of the arithmetico-geometric series.